Okay, so here we've got x minus 1 square plus 4. I'm going to try and sketch this. So the first thing we need to find is the y-intercept. So y-intercept, we said, so for A, y-intercept is when x equals 0. So if I replace x with 0, I get 0 for x. 0 minus 1 is just negative 1 squared, that's 1. 4 plus 1 is 5. So 0 and 5 is my y-intercept. The second one to look for is what we call the turning points. And we said the turning points happen when x minus 1 equals 0, so x equal 1, and the point is just 4. So if I plot these points, 0 and 5, so that's going to be my first point. And 1 and 4, x equal 1, that's we said was my turning point. So then, because I know I've got a line of symmetry here at the turning point, there's another point here. So if you were to sketch this, you would just go, this is how it goes. So what I'll do is I'm going to try a third one, 3. 3 minus 1 is 2. 2 square is 4. 4 plus 4 is 8. So 3 and 8 is where my point is going to go. So if you wanted to, you can add another couple of points just to help you a wee bit. So then to sketch it, you would just go through your points. Okay, so that's the first one, A. Now, if we were to do B, we'll adopt the same method. So y-intercept, where we cut. So I'm going to use a different color so that we can see even using the same graph there. So I'm going to use red this time. So y-intercept, I've got x equals 0. So 0 plus 2 is 2. 2 square is 4. 4 minus 1 is 3. So 0, 3 is my first point. Turning point happen when x plus 2 equals 0. Then x equal negative 2. And when x equal negative 2, because the first part is 0, you just get negative 1. So negative 2, negative 1 is this point here. So that's my turning point. So that means I've got symmetry here. Okay, so if I was to try another point like 1, for example, 1 plus 2 is 3. 3 square is 9. 9 minus 1 is 8. So 1 and 8 would be another point for me. And I've got 3 there and 3 there. So these 2 points, if I use the symmetry here, would be my other points, just to make it a bit clearer. And then you would sketch it. Okay. So that would be B. So C, we're going to do it. What color can we use? We can use green for C, I guess. I got green there, yeah. Again, so for C, y-intercept, x equals 0. Negative 4 square, that's 16. 16 minus 8 is just 8. So 0 and 8. So that's my y-intercept for this one. Turning point, x minus 4 equals 0. That means x equals 4. 4, and negative 8. So 1, 2, 3, 4, and it goes right up to negative 8, which is this one here. So turning point, intercept, I've got 4 here. I just need to add 4 to keep the symmetry. So I need to draw this. So I'm going to try and find another 2 points just to make it easier for me. So if I use 2, 2 minus 4 is negative 2. Negative 2 square is 4. 4 minus 8 is minus 4. So 2 and minus 4 is another point. And I've got as well these 2 points. So I've got enough points here to be able to draw this. Okay, so I've done my best, not being on a paper. So that's how you would draw these 3. So again, here, very similar things. We look for intercept. So I'm just going to do one of them, and that means you can do the other. So we're going to use black this time. So for A, y-intercept x equals 0. Y equal 1 plus 4 is 5. 0, 5. 0 for x, 5 in y. Turning point, x plus 2 equals 0. X equal negative 2. And I've got y equal negative 1. So negative 2, negative 1 is my turning point. So that means my graph is just going to go around there. If I've got 2 here, I get 2 here. So I'm going to try the value of 1. 1 minus 1 square. So something's not quite right. 0 and 5. So what did we say? X equal, oh, I'm doing the second one. Did I move to the second one here without noticing? I started with the first one.
I started with the first.
And then I started using, yeah, I made a mistake.
X plus 2 at the turning point.
So it should have been x minus 1 here. I started with A and suddenly I switched into B. So x minus 1 equals 0. Then x equal 1. And when x equal 1, I've got y equal 4. So 1 and 4. So we can ignore these ones. So I've got 3 here and 3 here. So I can try when x equals 0 to find out what we get. So when x equals 0, I've got 0 minus 1. Oh, we've already done. No, that's the intercept. Where did we put the intercept? 0 and 5. Something's not quite right. So when x equals 1, 1 minus 1 is 0, I get 4. But when x equals 0, I'm confused now. So where's the turning point? 1. Yeah, 1, y4. So the graph should be somewhere here. So let's try x equals 3. 3 minus 1 is 2. 2 squared is 4. 4 plus 4 is 8. So 3 and 8 would be, and because I've got 2 and 2, so my graph should be here. So that's A. So let's try B. So that would be 1 and 4 for the turning point. So I'm going to try B. I'm going to put it in red, and this time we'll try and make sure that we do it correctly. So B, that's red. First of all, when x equals 0, so y-intercept, x equals 0, y equals 4 minus 1, which is 3, yeah?
Yep.
So 0 and 3. Turning point, x plus 2 equals 0, then x equals negative 2. And that, when that happened, y equals negative 1. So negative 2, negative 1 is my turning point. So negative 2, negative 1,
Yep.
turning point. So I've got 2 there, so that should go here.
Mm-hmm.
I can try and find another point, point 1. So 1 plus 2 is 3, 3 squared is 9, 9 minus 1 is 8, so 1 and 8 would be my next point. And if I use the symmetry, 3 here, I would go here. We got there eventually.
Mm-hmm.
So that's the red curve. Okay, so that would be B. And C, let's do that in blue. Intercept 0, negative 4 squared, that's 16. 16 minus 8 is 8. So 0 and 8. Turning point, x equals 4, negative 8 for y. So when I've got 4, I'm at negative 8, which is here. So I've got 4 here. I need to get 4 here. Okay. So let's try when x equals 1. 1 minus 4 is negative 3. Negative 3 squared is 9. 9 minus 8 is 1. So it goes through 1 and 1 as well, which is 3 from there, 3 from there. It would go through here. So let's do C in blue. C would go like that. Come down and then back up again. Okay.
Yep.
So let's see. So this is how you would sketch a graph if you're given the completed square form.
But that's what I was saying earlier. You don't need to have like the actual coordinates like 0, 8 next to each bit. No.
You mean
on the if it just asks you to do a sketch, just do a basic sketch. Don't need anything else. It's not going to give you an extra point or anything.
Yeah. So basically, if it was a sketch and you'd be on a white paper, you could write here, for example, you could say this is 4, negative 8, just to make it clearer. And the other point you would be here, you would write, you've done 0 and 8. That's because we've got already a graph paper.
Yeah,
This
but it's
is
not going to give me any extra marks or anything doing anything like that, no.
No, I mean, you either do the graduation yourself, which takes you too much time, or you just put this is 0, 8, 4, -8.
Right.
And then you just make sure that you know that this is your symmetry here. So because you've got quadratic, then you've got 4 here, then another 4. Then here you would be at 8 and 8, basically. Don't have to write that one.
Okay.
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 So then you can try these FGH. Okay, so today we're going to use the graph to solve equations containing quadratic function. So how do we do that? So we did say that the quadratic function has this form, ax squared plus bx plus c. So it's quadratic because a is different than 0. If a was equal to 0, you would get a straight line. You know that bx plus c would be the same as mx plus c, for example. But we call it quadratic because a is different than 0. So the graph of a quadratic has these basic shapes, which is what we've just seen. It cuts the x-axis at 2 points with a smiley face, or it can cut them 2 points as well with a sad face. So we call these 2 points here the roots, meaning when y equals 0, what are the roots basically? And we've done that when we were looking at MAMS. Find the roots. It's to show you graphically where they are. So ax squared plus bx plus c equals 0 means you need to find those roots. Solve this equation. We've tried to do it by factorizing in the past. Okay, so let's try and do some example. Here I've got the graph of x squared minus 11x plus 28. Okay. And I know by looking at the graph that my solution for this would be 4, 0, and 7 and 0. So if you're asked to find the solution of x squared minus 11x plus 28 for this quadratic, by looking at the graph here, I can see straight away that it's going to be x minus 4 times x minus 7 without even factorizing this, because I've got x minus 4 times x minus 7 is equal to 0 here. So x equals 4, x equals 7. So another graph here, I've got x squared plus 5x. So for this one, you can put x as a factor, but you can see straight away that you've got the roots from the graph. We can see that x equals -5 and x equals 0. So if I was to factorize this, I would write this as x times x plus 5. And that does match the roots here, x equals 0 and x equals -5. And here, if you were asked to rewrite this, it would just be x minus 4 times x minus 7. And when we did MAM, remember we used to say, I need to find two numbers. If I time them, I get positive 28, but when I add them, I get -11. And you can see that -7 add on -4 would be -11, and -4 times -7 is a positive 28. Okay, so it's just working your way back the way by using graphs. So compare these first. let's say we've been given x squared plus 2x minus 8. So we've got a positive value for a if you were to rewrite it as ax squared plus bx plus c. So a equal 1, b equal 2, and c equal negative 8. So since a is positive, I've got a smiley face. So write down the equation, then substitute x equals 0 to find the y-intercept. So we've done that before. To find the y-intercept is when x equals 0. So here it'd be 0 and negative 8. To find the coordinate of the turning point, it's when all this is equal to its minimum. So minus b over 2a is the coordinate of the turning point. So b being 2, you substitute that. A is 1, so minus 2 over 2 times 1, negative 1. Then substitute negative 1 into y, you get 1 minus 2 minus 8, which is minus 9. So when you're given a function in this form, ax squared plus bx plus c, this is the formula to use to find the turning point. Okay. If you can't remember that, you can try and do what we've done. Can I rewrite this as a x minus something or x plus something times x minus something? So find two numbers. When you time them together, you get negative 8. But when you add them, you get 2. So it's going to be something with a 4 and something with a
Sorry,
2.
can you just say that again? I was just writing down the formula there.
Yeah, so let's say you can't remember the formula.
Mm-hmm.
So you should be able to factorize though.
Yeah.
Because you've learned that before. So to
Mhm.
factorize, you need to find two numbers. When you time them together, you get negative 8.
Yeah.
And when I add them, I get a positive 2.
Yeah.
So straight away, in order to get a positive 2, my bigger of the two numbers has got to be positive.
Mhm.
So that's why I know this is going to be x plus 4.
Yeah.
And to get a negative 8 is 4 times negative 2.
Okay.
So you could find the roots first. And remember what we said, if you've got the roots, so the roots is x equal negative 4 and x equal 2. So x equal negative 4 and x equal 2 are my what we called earlier on the roots. And the turning points is halfway between the two roots. So the turning point would happen at minus 4 plus 2 divided by 2. And that is negative 2 divided by 2, which is negative 1. So turning point when x equal negative 1, which is what they found here. So if you couldn't remember this formula, you could always get it back by finding the two roots, adding them together and half it. And when x equal negative 1, y equal, so you can do minus 1 plus 4, that's 3, times negative 1 minus 2 times negative 3, and that is negative 9. So you've got your turning point here, minus 1 and minus 9, without having to remember a formula. Because I always tell my student, try and see if there is other routes than just having one, other ways, to to find what you've been asked to find in case you sit during an exam and you think, oh, I can't remember this. Was it minus b over 2a? So you've got a way to find it. Okay. So we've got the coordinates. So we've got even more here because we've managed to find the roots as well, or what we call the x-intercepts. So once we've got all these, you write your coordinate, and then that's you. If you were to draw this, so let's see what we have. So the next thing, after having done the coordinate, the x-intercept, you just solve b squared minus 4ac is positive, so we are going to intersect the axis at two distinct points. So there are two distinct roots, which is what we've just been doing. We've factorized it. So if you do b squared minus 4ac, which is what they call the discriminant. So discriminant is another thing that we need to remember. So b squared minus 4ac. We'll look at it into another lesson too. That's what we call discriminant. Then we factorize x plus 4 times x minus 2. So you've got x plus 4 equals 0, which is x equal negative 4 and x equal 2. So these are my 2 points here, what we call our roots. So to sketch the graph, we've got everything we need. We've got our turning point, we've got our y-intercept, and we've got our 2 roots. And in this case here, we can just write it like this. That means you can sketch your graph with 4 points. Okay. So a couple of new things we've seen here is the turning point. We said when x equal minus b over 2a. And how do we know if we've got intercepts? Is looking at what we call discriminant. And if it's a positive value, we have 2 roots. Okay. So let's have a look for homework 1. Very similar to the example there. The first thing they've asked us here, calculate b squared minus 4ac and verify that the graph meets the x-axis in 2 distinct points. Find the roots and the y-intercept. Find the coordinates of the minimum turning point. Make a neat sketch of the graph. Okay. So we can pick one from that list. Which one do you want us to pick? A, B, C, D, E, F. So we can try D if you want.
Oh, yeah, okay.
So D. So first thing first, I just need to bring back the questions so that I know what they've asked us. So the first thing we need to calculate is B squared minus 4AC. Okay, so I'm just going to write down here. I need to identify what A is, B, and C. So for D, A is equal to 1. Remember, we've got this imaginary 1, invisible 1. B is negative 2, and C is negative 24. So I, to give me my first mark, b square, negative 2 square, minus 4 times 1 times negative 24. You put all that in your calculator and you get, so negative 2 square minus 4 times 1 times negative 24, and the answer I get is 100. So b square minus 4ac is positive. The graph meets x-axis at 2 distinct points, which is what we call the roots, right? That was the first question. I, find the roots and the y-intercept. So to find the roots, we need to factorize d. I need to find two numbers. If I time them, I get negative 24. And if I add them, I get negative 2. Okay, so I'm just going to write it here. How do I factorize d? This is what we used to call mam. Add would give me negative 2. And if I multiply, it would give me negative 24. So my numbers, I'm going to pick 12. No, not 12 and 2. I need to try 12. No. So what else can I try? 6 and 4. So what if we try 6 and 4? So I'm going to put x and a 6, x and a 4. To get a negative 24, one need to be negative, one need to be positive. The one that's going to be negative, it's the one that's going to give me negative 2. So then I can put x minus 6, x plus 4. Because negative 6 times positive 4 is negative 24. And if I add 6 and 4, I get minus 6 plus 4, which is minus 2. Okay, so we've rewritten y into a factorized way. So now you'd put roots is when y equals 0. That means x minus 6 equals 0 or x equals 6. And the other roots is x equal negative 4. Okay. So for the turning point, so that was the roots. We know it happens between 6 and 4. Divide by 2. So 2 divided by 2 is 1. So at x equal 1, what's the value of y? Y is going to be 1 minus 6, which is minus 5, times 1 plus 4, 5. Y equal 25. Okay, so I've got my turning points happening at 1, 25. Is that correct? Negative 25. I've got negative 5 here, guys. Negative 25. So, how do I find my y-intercept? So when x equals 0, when x equals 0, that's my last point. We just write y-intercept x equals 0, 0 minus 0 minus 24, negative 24. So how would you draw this in here? It's a bit harder because remember this is from 0 to 10. So what we could do, you could change this and decide that this is going to be 10, 20, for example. So you can change the y-axis as you wish. So if this is 10, this is 20. This is 25. Yeah. So let's say this is, we're going to change that to minus 5, minus 10, minus 15, minus 20, and minus 25. And you need to use the same scale above. So this is going to be 5, 10, 15, 20, and 25. For x, we're just going to use the scale that is here if we want to. So we said 6 and 0. So we're going to go through this point. Negative 4 and 0. The turning point, we did say it was at 1, which does make sense because from 6 to 1 you've got 5 square and another 5. And we said it's going to be 1, negative 25. So I'm going to go 1 right up to negative 25. Negative 24 is a bit harder because I've got 22.5 here. So 24 is about here. So now to sketch this, I've got 1, 2, 3, 4 points. I can add another point here if I wanted to. I can plug another point here to help me out. So if I've got x equal 4, what do I get? I get 4 plus 4, which is 8. 8 times negative 2, because 4 minus 6, which is negative 16. So when I'm at 4, I'm at negative 16. I'm about here. Again, 3, 3, so I'm about here. So I've got enough points to help me draw a sketch of my graph here. So that would go down here, down there, reach there, and back up again. That's how you would do your sketch. And you would write here 6, 0 for your roots, negative 4, 0. Your turning point, which is 1 and negative 25. And your intercept here, negative, so it's 0, negative 24. So we've got 1, 2, 3, 4. 4 points, enough to sketch D. Okay. So it's tedious, but you'll get there eventually. So we're not going to do this. So remember I mentioned something about discriminant, something that we called b squared minus 4ac.
Yep.
Let's look at what the discriminant really mean to us. What can we do with b squared minus 4ac? And remember, this is based on a quadratic in the form ax squared plus bx plus c. So it's quite useful because it gives us the nature of the roots. tells us a few things. So given this, ax squared plus bx plus c, the discriminant we said was b squared minus 4ac. This gives us some information about the roots. So we've got three possible things, right? When you calculate a number, the number can be either positive or negative, or the number can be equal to 0. So if you've got two roots, distinct roots, you'll find out that when you calculate b squared minus 4ac, your discriminant is going to be positive. So every time you're going to get a quadratic function, ax squared plus bx plus c, if you can identify a, b, and c and calculate b squared minus 4ac, if that value is positive, you've got two real and distinct roots. If, for example, your graph touches, or the x-axis is a tangent to the graph, touches the x-axis at one point only, then that means your b squared minus 4ac is equal to 0. So whenever you're going to get b squared minus 4ac equal to 0, you would need to state that with this quadratic, I've got two equal real roots. Yeah, so you might say to yourself, but I can only see one, but they're doubled. So you've got one and they're both one behind each other. Because we're dealing here with a quadratic function, technically we always expect to have two roots, and that's why when it's 0, you get this. Okay, so what happened now if the graph never cuts the x-axis? So remember, we've got discriminant positive, discriminant equals 0. So what do you think the discriminant is going to be if the graph never touches?
A negative.
Yeah, so if you calculate your discriminant and you find out it's negative, that means your axis is either above the x-axis when you've got a smiley face, or it's below the x-axis when you've got a sad face.
Yeah.
And that's when you'll find out. And you just say, I've got no real roots. Okay. So that's what it says there. So in order to state these three statements, I've got two real roots, two equal real roots, or no real roots, we need to calculate the discriminant. So now if I give you this quadratic, x squared plus 2x plus 3, and I'm asking you what is the nature of the roots? So you identify a, b, and c, which is quite straightforward here. A is 1, b is 2 here, and c is 3. We calculate b squared minus 4ac. So b squared is going to be 2 square minus 4 times 1 times 3, so 4 minus 12. So you can see here, I've got a negative value. And what did we say when we've got a negative value? The statement is we've got no real roots because the graph never cuts that x-axis. So during an exam question, you meant to say this. You calculate first b squared minus 4ac, and then you put that statement. Since it's negative, the nature of the roots, or you said, I've got no real roots. Okay, so three things to learn. Two real and distinct roots, two equal roots, or no real roots. So I've got another example. X squared plus 5x minus 6. So a, b, and c. This time a is 1, b is 5, and c is negative 6. So b squared is going to be 25 minus 4 times 1 times negative 6. So a negative 4 times a negative 6 will give me a positive 24. So 25 plus 24, which is 49. So here, the statement to write is, since b squared minus 4ac is positive, I've got two real distinct roots. That means your graph would cut the x-axis in two places. So I've got x squared plus 6x plus 9. 1, 6, and 9. So I expect this one to be 0 somehow, because 6 squared is 36. Take away 36. B squared minus 4ac is 0. Then you said, because my discriminant is 0, I've got 2 equal real roots for this quadratic. Now, they may be a bit cleverer by asking you to find the value of, here I've got A is 2, B is 4, C equal P. So I don't know what P is, but what they've told me is I've got real roots. So find the value of P when you've got real roots. And what did we say we've got real roots? When B squared minus 4AC, you can either have 2 equal real roots or 2 distinct ones. It's got to be positive or equal to 0, yeah? So that's the statement you need to write. B squared minus 4AC, to get real roots, it can either be the 2 when it's equal to 0 or when B squared minus 4AC is positive. So we need to solve this. So how do we solve 16 minus 8P is greater than or equal to 0? So the way I would do it, you can say, okay, I've got negative 8P is greater or equal than negative 16. So in this case, what they've done is they've taken away 16 from each side. Because they're happy to work with negative values. The next stage, because we're going to divide by negative 8, when you divide by a negative number, an inequation, you need to flip the sign whenever you divide by a negative number. And that's when, to answer this question, find the value of P given that has real roots. P can be any number less than or equal to 2. So 2x squared plus 4x plus 2 would give me real roots, or P equal 1, etc., etc. Okay, so that's how you would answer that kind of question. So we're going to take a break, and then we'll look at a couple of these questions together, and that means you'll be able to do homework number 2. So I'm going to pause here the recording, or stop it.